Hello students, this is Smita Patnaik from Electronics and Telecommunication Department. So today we are discussing about one more new topic, that is your signal flow graph. Okay, so signal flow graph is a diagram that represents a set of simultaneous linear algebraic equations. Okay, so it is a pictorial representation of the system which displays graphically the transmission of a signal. As discussed in previous class, block diagram. So this signal flow graph is a one more pictorial representation, that is graphically the transmission of signal. Okay. Next, a signal flow graph consisting of a network in which nodes are connected by directed the branches. So here it depicts the flow of signal from one point of a system to other point and gives the relationship between the signal. Okay. So next we discuss some basic elements of signal flow graph. Here are some basic elements. First one is your node. Okay. Node means what? A point representing a signal or variable. All dependent and independent variables are represented by a node. So here this node is again divided into three types. Okay. First one is your input node. Input node is otherwise called as your source node. Okay. So it is a node which associated with the outgoing branches. So here which has only outgoing branches. And next one is your output node. This output node is a node which has only incoming branches. This output node is also known as your sink. So next come to your mixed node. Here it is a node which has both incoming and outgoing branches. So this type of node is also known as your channel node, which connect both input and output node. So take this example to understand easily. Okay. Here let's see this diagram which is consisting of how many nodes? The nodes present in the signal flow graph are Y1, okay, Y2, Y3 and Y4. Okay. Here Y1 is called your input node. That is also known as your what? Source node. And last one is your Y4. That is also known as your output node or sink. Okay. In between Y1 and Y2, it is clearly visible in this diagram that in between Y1 and Y4, two nodes are there, that is Y2 and Y3. Okay. These type of nodes are known as your mixed node, or that mixed node is otherwise called as your channel node. Okay, which can connect your input node and output node. Okay, here also you see in this diagram some gains are there, that is your A, B, C and minus D. Okay, here let's see path. Okay, Y1 to Y4. Path means what? It is a collection of continuous branches from input side to the output side along one direction only. Okay, it is clearly visible in this diagram. From input means Y1 to Y4, there is a path having single direction. Okay, so next, path gain means what? Here it is the multiplication of gain of the individual branches along a path. Okay, here one more basic element is there, that is your forward path. Okay, in case of forward path, what happens? It is a collection of continuous branches from input to output in a same direction. Okay, means Y1 to Y4 is called your forward path because it is having a single direction. Okay, so next let's discuss branch. Okay, branch means what? The branch is a line segment which joins two nodes. Okay, it has both gain and direction. For example, there are four branches in the above signal flow graph, okay, which was discussed earlier. Okay, here these branches having gain how much? I am told you that A, B, C and minus D. The connecting line between two nodes is called branch. Next path also I discussed. Okay, next loop. Okay, this one is interesting. Loop means what then? A closed path that originates and terminates on the same node, and along the path no node is met twice. That is called your loop. Okay, it is a complete closed path. Okay, and loop gain. And the gain of a loop is known as loop gain. In the previous diagram, one loop is there and the loop gain is what? Minus D. Okay. Next, here non-touching loop. Non-touching loop means what? Loop, you understand? A closed path. Okay. Then what is non-touching loop? Two loops are said to be non-touching if they do not have a common node. That is called your non-touching loop. There are some non-touching loops are there. We will discuss later. Okay. So here this one is the Mason's gain formula. Okay. This one is very important chapter. Okay. Here Mason's gain formula means what? The relationship between an input variable and an output variable of signal flow graph is given by the net gain between the input and output nodes is known as overall gain of the system. Okay, I hope you understand. This one gives the formula for find out the Mason's gain. Okay, it can be represented as a capital M. So here what's the formula then? Capital M equals to 1 by delta summation of k equals to 1 to n pk and del k equals to x out by x in. So how we can find out the gain of the, that is the ratio between output to input. Okay. So let's discuss here where m equals to gain between x in and x out. Okay students. Next, x out equals to what? Output node variable. Okay. X in equals to input node variable. Okay. Next, n equals to represents total number of forward path. How much or how many forward paths are there? And pk represents here path gain of kth forward path. Okay. And last one, delta, whose formula is 1 minus sum of loop gains of individual loop. Okay students. Next, plus sum of what? A gain product of all possible combinations of two non-touching loops minus sum of gain products of three non-touching loops, etc. Okay, dot dot dot. That is the formula for find outing the Mason's gain. Okay, so let's check. By taking one example, we can find out. Okay, so this one is the question for you students. Okay, here what happens? The question is given, that is find the transfer function. T by F means transfer function of the signal flow graph. Okay, here just see in this diagram, this one is the signal flow graph. Here we have to find out the transfer function. Okay, so here let's check. First one is your R of S. Okay. So R of S means what? Your input. Next, last one is your C of S. Okay. So C of S means what? Output. So here what we have to find the transfer function, means output divided by input. What is then output? C of S divided by R of S equals to transfer function. Okay, so let's find out. First, you have to find the total forward path gain. Okay, so forward path means what? How will you find forward path means? I am already told you that forward path means the path between from input to output. Okay, so here T1 represents the total forward path gain. Okay, here path gain means what? G1. Here see, from input to output, input is what? R of S. From input G1S, next G2S, G3S, G4S and G5S, having a single direction. Okay, so it is from input to output. So this path is called your forward path. Okay, so this forward path is represented by your T1, and T1 is your what? G1S. You have to multiply all these gains. Okay, so G1S and G2 of S, G3 of S, G4 of S, and last one is your G5 of S. Okay, so how will you find out? The forward path means it is a collection of continuous branches from input to output in a same direction. Okay, next what you have to find? Closed loop gain. Okay, first you have to find the loops. Okay, here how many loops are there? First loop you check. This one is G2fs and H1fs. Here G2fs is and H1fs. This one is your one loop, and second comes to G4fs into H2fs. Loop means what? It is a complete closed path which originates and terminated at the same node. Okay, which starts from the same node and also end at the same node. So first loop is your G2 of S into H1 of S. Second loop is your G4 of S into H2 of S. Here third loop is also there, that is G7 of S into H4 of S. Okay, I hope you understand well. Okay, next fourth one, here is a larger group is there, that is your G2 of S, G3 of S, G4 of S, G5 of S, G6 of S, G7 of S and G8 of S. It's starting from G2 of S and also ends in G2 of S. So this one is the larger group in this transfer function. Okay, so this one is your fourth number of closed loop. Okay, let's next find out the non-touching loops taken two at a time. Okay, how many non-touching loops are there in this diagram? First you have to find out. Okay, here let's check how many non-touching loops. Here first non-touching loop is your loop 1 and loop 2. Loop 1 means what? Your G2 of S into H1 of S. Okay, next second loop is your G4 of S into H2 of S. So these two loops are non-touching loops. Non-touching loop means what? Loops having no common node. Okay, here there is no common node between two loops. Okay, so here next non-touching loop, that is one group. Okay, G2 of S, loop 1 and loop 2. You have to multiply loop 1 and loop 2. So what is the value? G2 of S into H1 of S, G4 of S into H2 of S. Similarly, next, how many non-touching loops are there? Yes, there are again two more non-touching loops, that is loop 1 and loop 3. Okay, so in these both loops, there are also not same common node. Okay, so you have to multiply loop 1 and loop 3 also. Next, one more non-touching loops are there, that is loop 2 and loop 3. Okay, you have to multiply in similarly. So next what you have to find? Non-touching loop taken 3 at a time. Okay, here how many non-touching loops are there? 3 at a time. Okay, here loop 1, 2 and 3. Yes, but loop 4 is touches here, so that it is not taken as a non-touching loop. Okay, but loop 1, loop 2 and loop 3 are non-touching loops, that is taken 3 at a time. Okay, so Let's see here, non-touching loops taken 2 at a time. Already told you loop 1 and loop 2, whose value is G2 of s, H1 of s, G4 of s, H2 of s. Next, loop 1 and 3 also non-touching loops. That's value is G2 of s into H1 of s, G7 of s into H4 of s. Next, third loop, loop 2 and loop 3. That is your G4 of s into H2 of s, G7 of s into H4 of s. Next, you have to find non-touching loops taken 3 at a time. Okay, so here 1, loop 2 and loop 3. Okay, loop 1, loop 2, loop 3, you are non-touching loops, so you have to multiply these 3 loops at a time. Okay, next you have to find the delta. Okay, so what is the formula for delta? I have already told you that delta equals to what? 1 minus sum of what? Individual loop gains plus, here how many individual loop gains are there? We have already find out loop 1 plus loop 2 plus loop 3 and loop 4. Okay, I hope you understand. Sum of individual loop gains. How many loop gains are there individual? 4. So you have to add all that loops. Okay, plus sum of two non-touching loop gains. Okay, so how many two non-touching loops are there? 3. So you have to add these 3. Loop 5 plus loop 6 plus loop 7. Two non-touching loops minus sum of 3 non-touching loop gains. Okay, here how many 3 non-touching loops are there? Loop number 1, 2, 3. Okay, that is your 8. So, for what is the formula then? Delta equals to 1 minus loop 1 plus loop 2 plus loop 3 plus loop 4 plus sum of 2 non-touching loops minus sum of 3 non-touching loops. Okay, you have to put the values in this formula. Next, find out the value of delta 1. So, delta 1 means what here? Delta 1 equals to formula 1 minus non-touching loop in forward path 1. Okay, so how many forward paths are there? We have only single forward path, that is T1. Okay, so you have to find the loop which is not touching the forward path 1. Okay, so here only one loop is there, that is your loop number 3. Okay, that is not connected with the forward path 1. So 1 minus G of s into H4 of s. Okay, so you have to put the value in delta 1 equals to 1 minus non-touching loop in forward path 1. Okay, so delta 1 equals to how much? 1 minus G of s into H4 of s. So here all values are calculated, then only put these all values in the above formula. So we have known that transfer function is represented as G of s, that is equal to C of s divided by R of s. So what is the formula then? T1 delta 1 divided by delta. T1 equals to our forward path into delta 1 equals to, we also find this value 1 minus G7 of s into H7 of s divided by delta. Okay, we have put all these values in this formula. So this is the answer. I hope you understand. Thank you.